next up, we have Marcus Jecklin. Marcus, it's here. You are the co-founder and chief marketing officer for AI4. Did I say that right?
Yes,
AI.
yes.
Okay. Uniting the global AI ecosystem through events and media, which is really interesting. So what I also understand is you are creating the largest and most influential venue for AI-related idea sharing, commerce, and technological progress, right?
That is correct.
Okay. Another one, building community. And so that's actually what you're here to talk to us about, building a community around AI. So I'll turn it over to you.
Yes, yeah. Thank you guys for having me. I'm a big fan of this event, and I really appreciate being able to join today to talk about building a community around AI. Let me just pull up my slides here. Hopefully I can share my screen. To introduce myself and set the stage for you a bit, I'm an event organizer, and I've spent the past 3 years building a global ecosystem of AI leaders from the world's largest and most innovative private and public sector institutions. Over the past 3 years, my company AI4 has convened over 20,000 people virtually and in person at our events to discuss what's happening with AI and how to best leverage it from a business perspective. In this talk, I want to share what I've learned while building my company to help give you a better understanding of what's going on in the AI community and how this game-changing technology is going to impact everyone here. If you're already an expert on AI, that's great, but you might not get too much value from this presentation. I do, however, encourage you to join me at our next event coming up this August. For everyone else, let's get started with a few common misconceptions. Misconception 1, the AI takeover. So probably the most common question I get from friends and family is, when is AI going to take over? And I hate to break the bad news, but AI has already taken over. The bots are out. Companies and governments around the world have entered into a massive AI race for fear of getting outpaced by an AI-powered competitor. By 2030, PwC estimates that AI will add $15.7 trillion of value to the global economy. While such stats can be somewhat vague, the point is that AI is real, and every organization is moving in the direction of becoming an AI company, the same way every company had to become an internet company 20 years ago. Amazon Alexa and Apple Siri are two of the biggest experiments in the world going on right now in natural language processing, a type of artificial intelligence known as NLP. The term natural language processing is basically just science speak for anything that has to do with voice or text. It's one of the most explored applications of AI right now. And from my experience hosting conferences, basically every organization in the Fortune 500 is either doing it or is starting to think about it. The reason why these mega companies really love AI for voice and text is because they all have massive amounts of customers, and the preferred method of communication for humans is speech and writing. So having a bot that can actually understand what a human is saying, especially if it can respond back, is incredibly helpful for cost cutting. I'm sure everyone here has had an experience with AI while calling a customer service number or while typing with a chatbot. And while these conversations can be incredibly frustrating, they are saving the largest companies in the world millions of dollars per year on call center staff. Beyond customer interactions, large companies have vast troves of internal documentation that's ripe for NLP applications. Each hospital, for example, has thousands of handwritten doctor's notes. Another highly visible application of AI is what Elon Musk and others are trying to do with self-driving cars. Self-driving cars are a great example of the second most prevalent application of AI, computer vision. You can probably guess what computer vision algorithms do. They basically just analyze images and video. Unlike Tesla, most computer vision is being used in slightly more discrete ways. We found the world's largest healthcare companies are starting to adopt computer vision for medical imaging. Things like X-rays, CT scans, MRIs are now being analyzed at least in part by machine learning models. Even crazier, these machine learning models are consistently outperforming the very physicians that help build and train them. But don't worry, those AI algorithms are still being supervised by real humans for the time being. In finance, a cool example that's often discussed at our conferences is using AI to analyze alternative data to help make trade decisions. For example, There are companies assessing satellite images for parking lots to count cars and predict revenue for retailers like Walmart before their quarterly earnings reports come out. In agriculture, drone images can detect when crops are at risk. In manufacturing, autonomous factory robots can see where they're going. And in retail, store managers know when you missed a scanned item in the self-checkout line. The use cases truly are endless. The third extremely common use case for AI is something called recommender systems or recommendation engines. And they're exactly as they sound. Recommendation engines are able to leverage your past behavior to make predictions about what you're going to do in the future. Netflix and Amazon rely heavily on recommender systems to suggest movies and products based both on what you've watched or purchased, as well as what movies or products others like you have enjoyed. Google also now uses AI in their search feature, so every time you hit enter, you're interacting with an AI algorithm. Is it all a little freaky and intrusive, or is it incredibly useful? Most people, including legislators, are still making up their mind. So is AI taking over? Yes, I think it certainly is. But with all the bots loose in the world, not a single one has turned evil just yet. However, there are certainly bad people trying to leverage AI to do harm, but I'll get into that later. Misconception 2, AI is new. The second misconception that I want to address is the notion that AI is new. How many people here thought that AI was basically a new thing, something that happened in the last several years? The reality is that AI as we know it, the AI that you hear people referring to as machine learning, is really only the most modern form of AI. However, it is by far the most exciting iteration of AI to date. The basic definition of artificial intelligence, according to Google, is the theory and development of computer systems able to perform tasks that normally require human intelligence. But that's pretty vague, isn't it? Based on that definition was the abacus built by ancient Mesopotamians in 2700 BC, actually the first AI. It certainly has highly intelligent capabilities and can do things that humans can't, such as multiply large numbers or even take square and cubic roots. But okay, that was just a stupid looking wooden contraption that you probably could have invented yourself with enough free time. But how about the invention of the calculator in 1890? That's much more complex. And at the turn of the century, it definitely would have passed the test as an intelligent machine. The point I'm trying to make is that the term AI is incredibly vague. An abacus, calculator, and an Amazon Alexa all represent forms of AI. However, only the Amazon Alexa meets the modern day definition of what people really mean when they say AI. And what people really mean is machine learning. But more on the technical details of that later. All of that was really just a long-winded way of saying that AI is not very new at all. But okay, how about machine learning? That must be pretty new, right? Actually, it's not. You might be surprised to know that the concept of machine learning is almost 70 years old. At Dartmouth College in the summer of 1956, a man named John McCarthy, who was working as an assistant professor of math, gathered 11 people to develop ideas about thinking machines. And it was here at this conference that the term artificial intelligence was coined. So what happened then? Why is everyone just starting to talk about AI if it's been around for so long? As it turns out, the technology has undergone several waves of popularity since 1956 because the technology continuously overpromised and underdelivered. Who remembers when Deep Blue beat Garry Kasparov back in 1997? This was a huge win, but it didn't lead to any immediate commercial applications of AI. Prior to today's version of AI, all of the other breakthroughs ended up disappointing those who funded them, leading to those several AI winters where research was stalled and hope for various projects was lost. Until now, there's been a pretty big disconnect between our conceptual understanding of AI and the actual ability of engineers to build intelligent machines. But today is a special time in history. For the first time, modern computing power can actually handle the vast amounts of data we've collected, enabling data scientists to train AI models capable of doing intelligent work. The key breakthrough that allowed AI to become so widespread is the GPU, which is a piece of computer hardware, but we won't get into that right now. The point is made, I think. AI is not new, but it is only recently successful. Misconception 3, I can't understand AI. The next misconception I want to address is the notion that everyone has that AI is too complicated for them to understand. Who here is intimidated by the words machine learning and neural nets? Who here has even heard the word neural nets before? People's eyes usually glaze over when they hear words like this, but sincerely, you can understand this stuff. Okay, maybe you won't be able to actually build an AI model yourself by the end of this talk, but there are a ton of resources out there waiting for you in case you do. Just Google free beginners Python course. For the rest of us, myself included, who don't feel like they have a good reason to learn to build an AI model from scratch, let's go on a short journey together. Machine learning is a type of AI that allows computers to learn tasks instead of being programmed to do them in the traditional sense. Here's an example of how this works from Kevin DeWalt's book, Become an AI Company in 90 Days. So let's say that we want a computer to make decisions about whether a number is too high. A developer could write a program that looks like this. Even if you've never done programming before, you can pretty easily tell what this program is going to do. First, it establishes that the maximum value of a number is 10, and then it checks each number to see if it's greater than 10, printing out the result at the end. Here's what the output might look like after feeding it a string of numbers. But here's the real kicker. How did the developer know that the maximum value was 10? Well, either because she figured it out, or because somebody, possibly a customer, her manager, an analyst, the CEO, told her. But what if that special number isn't always 10? What if on Wednesday, any number greater than 11 is too high, but if it rains, any number above 9 is too high, and for a child, 10 is okay, except past 5 p.m.? What you can see is that real life situations are complex and constantly changing. Sometimes it's even impossible to know all the variables that might be considered in a single decision. And this is where AI becomes very useful. Using machine learning, we can build flexible systems that adapt to new conditions in real time without having to rewrite the entire program. But how do we actually do it? The most important thing to understand is that in order to build a good model, we need to teach the model how to do the task using training data. In my example, you can see that I've got a training data set of 6 numbers with the desired output listed next to each. This is the data that's going to be fed into the model. Next, we must teach the algorithm whether or not a number is too high. To do this, the developer shows the model a list of numbers, and the model takes a guess at whether or not the numbers are too high or okay. Simultaneously, the model gets feedback as to whether or not the guesses were correct. In much of the same way a human learns, there's a feedback loop created that reinforces correct answers while discouraging incorrect ones, so that gradually over time, the model improves. The nuance here is that the developer doesn't actually need to know that the maximum value is 10. The developer only needs to have sample data that's correctly labeled. Once the model is fully trained, it can then be deployed and begin making decisions in the real world. I think this example can come across a bit silly when we're only talking about judging whether or not a number is greater than or equal to 10. But imagine if our training data set was 10,000 chest x-rays of lung cancer. Could you write a set of rules by hand that correctly diagnose these images 99.9% of the time? These incredibly complex problems are nearly impossible to write rules for in the traditional programming sense, but lend themselves very well to machine learning applications. This, in essence, is machine learning. It's tough, but it's not rocket science, and it's definitely not too hard for you to understand. Misconception 4. Evil AI. I think a lot of people out there are spreading bad rumors about AI. So let me cut to the chase. AI is simply not going to become evil anytime soon because it does not have the opportunity to do that. Not yet, at least. From this talk, I hope that you're slowly getting the sense that AI is really good at very niche applications, like determining whether a chest X-ray is or is not cancer, but very bad at complex tasks that require intelligence in more than one area. This is why most modern jobs are still safe. The thing that you should be afraid of is the point at which a single algorithm truly does become smarter than humans in most dimensions. People in the community refer to this as AGI, or artificial general intelligence. There are many expert opinions about when AGI will occur, which range dramatically, but the averages seem to fall around 2060. The point at which AI becomes smarter than humans is called ASI, or artificial superintelligence. Theoretically, when we hit ASI, the AI will be capable of creating better versions of itself, and it's at that point that humans might not be necessary anymore for purely intellectual tasks. Of course, to take over all human tasks, you've got to pair that superintelligence with some type of robotic body, but don't worry, there are companies working on that too. We showcased this dog-like robot named Spot at our last AI conference. But okay, let's get back on topic. Evil AI is not a threat today, but bad AI certainly is. And it's definitely something that every Fortune 500 is thinking about. AI poses massive amounts of business risk for many reasons. AI bias is a huge theme at our conferences right now. Bias can sneak into our algorithms in many ways. One way this can happen is if you build your model based on training data that's skewed in some meaningful way. When that happens, the consequences can be far-reaching because the models used by many companies are deployed at such a large scale. Imagine that a model used by a major bank to establish creditworthiness accidentally learns that people of a certain race or age or gender are less creditworthy. It's not only an issue of ethics in this case, but it's also potentially illegal. There are a few solutions to the AI bias problem, including the first, which is just maintaining really good data practices, doing things like spending time and energy on eliminating potential sources of bias before the data goes into the model. The second way you can eliminate bias is to build something called explainer AI, which is basically just an AI that can explain itself in human terms instead of spitting out a black box decision. The third solution, though, is what most Fortune 500s are doing, which is to build an AI ethics board. The board's job is to carefully review all models and methodologies for ethical concerns. The other big concern we're seeing is data privacy. Since AI needs massive amounts of personal data to work, in fact, the more data, the better, it's kind of a double-edged sword because on one hand, it's creepy and intrusive, but on the other hand, it actually has the potential to add value to our lives. The EU has started to crack down on data privacy with GDPR, but the US is not there yet. Eventually, it's probably inevitable that you're going to be able to choose what private companies get your data, which don't, and how much of it they can see. Data truly is becoming the world's most valuable commodity. The solution to the data privacy problem is regulation, but as we all know, innovation and technology always seems to outpace regulation. There are many other ways that AI can go wrong, including mistakes made by robots, weaponized AI, and much more. But we don't have time to discuss everything here. Misconception 5, job loss. Who isn't at least a little bit afraid that their job is going to be automated? In the short term, you're probably all fine. But generally speaking, the more unique tasks your job requires, the more varied it is, and the less clearly defined it is, the safer you are. Currently, AI is augmenting, but not replacing jobs. By this, I mean that people like radiologists are working alongside AI in order to make their jobs more efficient. If you're interested in the 1,000,001 ways that AI is augmenting and not yet replacing jobs, check out this book. It's incredibly comprehensive. But if you don't have time to read the whole book, maybe just look at this graph instead. What you're looking at is a graph from the New York Times of unemployment from the past 15 years. Do you notice anything interesting about this graph? During the most recent explosion in AI, which started around 2013 and is still going today, the unemployment had actually decreased to record lows around 4%. Now compare that to this graph of AI funding. What you can see is that, if anything, there's actually a strong negative correlation between the two. As AI development has increased, unemployment has actually decreased. If I go back to this graph, you can see that what really causes unemployment has little or nothing to do with technological progress, but other economic factors like a recession caused by the housing crisis or this pandemic that we're all still living through. The media loves to paint these alarmist pictures of what's going on, but generally there's no need to sound the alarm just yet. And I'm really not sure there ever will be. So to wrap things up, what's the point of doing conferences and building a community around AI? Why does my business exist? The answer is very simple. The first reason is that innovation rarely happens in a vacuum. It's through collaboration and teamwork that most great things are achieved. The second is that nothing replaces a firsthand experience. You could spend 10 hours reading a book about how to ride a bike, but I bet you could learn more in just 10 minutes of actually trying. The final reason is that conferences are helpful for spurring innovation, and that progress requires a deadline. Without the deadline of this conference, I assure you, I never would have finished this speech. So let that be evidence enough. That's all I've got time for today. I hope you all enjoy the rest of your conference, and thank you all for listening.
Marcus, thank you so much. I will tell you, I was misconception number 3. It's too difficult, but you do have a gift for helping people understand it. So I thank you for that. Where can folks go to get more information about your August event?
Go to AI4.io.
Okay.
You can find everything there.
Easy enough. All right. Thanks again for being with us. Appreciate it.
Awesome. Thank you so much.